Hi everyone, welcome to my YouTube channel Tech Data Engineer. So in this video we will see what is scaling, why we required scaling to our system. Okay. So this is mostly asked in case of system design. Okay. So if certain questions arises like how you'll design your system, if there is an existing system, how you will scale up or scale down based on the load balancer or based on the requirement. Okay, so you should understand like how in which scenario we have to do vertical scaling, in which scenario we have to do the horizontal scaling. So scaling is something we have to increase something or decrease something, scale up or scale down based on the requirement, right? Like suppose I'm giving a scenario. Suppose you have a data to process one GB of data, right? For that you required one core CPU and then two GB of RAM, something. Just an example. If you wanted to process 2 GB data, then you have to increase your you can say capacity of your engine. Okay, so that is called scale up. If you wanted to reduce the capacity, that is called scale down. So there are two scenarios where we can do the scaling, that is called vertical scale and horizontal scale. So if you are designing the system, you should aware about these two terminology, vertical scaling and horizontal scaling. Okay, so what is vertical scaling first of all? So vertical scaling is nothing but if you have existing machines, so increase the size of the instance. Okay, you don't have to increase the instance. So if there is existing machines of 2 GB RAM and 100 core CPU suppose, or 2 core CPU 100 GB of RAM suppose, you can increase by 4 GB or 8 GB, and you can increase the two from 2 core to 4 core, 8 core, 10 core, and increase the corresponding their RAM also. But you don't have to increase the instance. Okay, instance means you don't have to create the cluster, you don't have to create the different server. You can, so in the same existing server you can increase their capacity. Okay, and what is horizontal scaling? So horizontal scaling is something where you will add more instance instead of adding the extra configuration to the existing machines, you can add the more instance. So that is called horizontal scaling. So in vertical scale, there is existing machine, you can increase their capacity or processing power. Okay, then it will scale up in vertical way. If there is a machine, the same replica machine, you can make it, you can add it to the instance or you can add to the pool. Okay, that is called horizontal scaling. Okay, we will see the theory part also. So adding more machine or instance to handle the increased load. So in case of horizontal scaling, that is called scale out also. You can add more machine or instance to handle the increased load. Okay, so there is a one existing machine, you can add one more, and you can add to our pool. Okay, so how it works basically, horizontal scaling, you add more server to a pool so that system distribute the workload across them. Okay, so suppose there is a 1 GB of data and there is a one machine, so 2 GB of data came, and if we have increased the two machines, the same load will be distributed across both the machine. Okay, so this is called horizontal scaling. So in case of horizontal scaling, what we are doing, instead of upgrading a single wave server, okay, you add two to three more machines and use a load balancer to spread the traffic. Okay, so you have to add the load balancer also here to distribute this load eventually on across all the machines. Okay, so if we are doing, if in your interview, if system designing comes into picture, so there is a very much chance that based on the scenario, they will ask you the questions like, in this scenario, you will scale your system horizontally or vertical. Okay, so you should aware about that. Okay, in case of interview. So what is the pros and cons for that? So pros is better fault tolerance. Why fault tolerance? Because suppose one machine got failed, then it will handle the other. It will be handled by other machine. But in case of vertical scaling, if one machine got failed, there is no fault tolerance because there is only one machine. Okay. So better fault tolerance. If one server fail, other can take over. Easier to scale, infinite. In case of theory, you can say you can add any machine. Often cheaper long terms in cloud environment. So that is Okay, so what is the cons for that? More complex architecture. So if you add the more machine, there would be a complexity to managing all these machines. Okay, harder to manage, so more moving parts. Okay, so it is a bit harder to manage also. Coming to the vertical scale, that is called a scale up. So vertical scaling, adding more power like CPU, RAM, storage with the existing machine. Suppose there is a 2 core CPU, 5 GB of RAM or 10 GB of storage, then we can increase from 2 core to 8 core. RAM is 20 GB, storage is 100 GB, something like that. Okay, so upgrading your current server to handle the more workload. Instead of adding the server, here what we are doing, we are upgrading the same thing. What is the pros for that? The pros is simple to implement. Yeah, you don't have to add the machine. This is very simple. No need to redesign your architecture. Yeah, so there is no load balancer required. You don't have to redistribute your things. Okay, so these are the pros. So this is simple, and this is easy to implement also. No need to design your architecture. What is the cons for that? So cons is there is a physical limit to your physical limit to how much you can upgrade. So okay, so for existing machine there is a physical limit, single point of failure. So if server crashes, everything goes down. Okay, you don't have there is no options that you can up your machines there, so there is no fault tolerance basically. Can get expensive at high tiers also, so sometimes gets expensive also. Okay, so this is basically difference between horizontal scaling and vertical scaling. Okay, thank you, thanks for watching.